Hello everyone. So today we will be solving maximum total importance of rows. So this sum is quite simple. Coming up with the solution is quite simple, but to implement it could be a little bit tricky. Uh, so what does this problem say is that there are nodes now labeled from 0 to n, and you have to label them again with values from 1 to n, such that the cost becomes maximum. And how do we calculate the cost or the importance? Basically same thing. They are just changing the name so that they could look little bit different, I guess. Yeah. so so what does how do we calculate importance or a cost? So cost between two nodes is, let's say between node 1 and 2 at will be 4 plus 5. So basically the label value which you assigned both the nodes. So the summation of both the labeled node will be the cost of that you know that connection. So you have to maximize it. So basically this problem combines greedy with the graph. So in this the nodes which has maximum in degree will you will be labeling with the maximum value we can label, right? So So let's use this. So here you can see, what do I mean by in degree is that the number of connection it has. Like here you can see that 2 has connection with 3 different nodes. So basically the in degree of 2 will be 3. So we will be labeling maximum value which will be 5 and assigning it to the 2. So why we are doing it? Because it has maximum number of connections. So it will be impacting multiple nodes all together. Like it is quite intuitive if you look into it. Only the tricky part is that how do we code it? So initially what you can do is that we can say that we have to basically get the in degree of each and every node. So what we can do is that we can actually create an in degree array. Let's call it in something equals to in degree new int of size n, and we will be basically looping over the rows array like this. And uh, and we will be doing this. First, let me write you, and then I will be explaining it to you. A of 0 plus plus. We have created, in degree of each and every node. So what we can do is that we can create a list of pair. Where we can store, node and its in degree. Basically creating, key value pair where key will be node and value will be its in degree. Now don't say why I'm not using hash. Okay, so I will be basically looping over in degree array I equals to 0, I less than, and I plus plus this dot add new pair array of, sorry, where in degree of, where I is the node and in degree array will give us its in degree. Makes sense. Now you have to sort collection dot sort. But like our compiler doesn't know like on basis of what it should sort. Like should it give more priority to the node? Should it give more priority to the integer? So that we have to implement using comparable interface. So what we can do is that we can just simply type implements comparable, and it's pair, and we can basically override this, not override, but I just pasted my old code. Yes, let's understand that afterward. So what does this do is basically public int compare me. So this is the method which we have to implement, and we are passing pair o. So what does O mean? O means other. We are very creative. That's why we named it. So I hope you get my that. So yeah. So what basically we are doing is that comparing this integrity with other pairs integrity. And what does this represent? This whenever you type this dot integrity before the or dot integrity, that represents that the integrity of the integrity of this element should be lower than the other. Basically, we will be sorting the array on in ascending way on the basis of integrity. So the first position will have the least integrity. So after sorting, basically we can print the array and see what's going on. And return some garbage value. Let's say this. So we cannot see much, right? Like I'm very smart guy, that's why I can understand what does this 73A80FC means. But you might not, right? So what basically we have to do is that we have to override toString method to be able to see what's going on in your pair. Basically. So like I have written this code where I added this bracket just for better visualization, nothing else. So I'm returning this dot node and this dot integrity. So first value will be the node and its integrity. Here you can see the integrity, the least integrity is 1, and the 2, 2, 3, 4. So we have sorted on the basis of integers, and here are the node values of that particular integer. So using this knowledge, what we can do is that we can assign certain values on the basis of their integer, right? So we have list arranged in the ascending order. So the integer which is least will be given to the node present at the 0th position. So we have to give it the least amount of points, or the least amount of value which we can possibly give, because we want to save the maximum amount of value for the node which has maximum integrity. So what we can do is that basically loop over it. Int I equal to 0, I less than n, and what we can do is that this integrity array is useless, right? So we are not using it anymore. We are used for this. So save a little bit of to save a little bit of space, we can basically repurpose this array. So integrity of list dot get at ith position node should be equal to I plus 1. Why I am writing I plus 1? Okay, so let me make you understand that what does this line do. So basically, what I'm doing here is that the node that is present at ith position. So list dot get the pair at ith position and its node. So like basically I'm assigning its node value to the I plus 1. So for let's say I equals to 0, basically in 4, right? So I will be going to the integrity array location 4, and I will be assigning it the value I plus 1. And in this case, I is 0, so basically 1. And why am I assigning it 1? Because we have to assign numbers starting from 1 to n, not from 0 to n minus 1. Like those are the node values. From 0 to n minus 1 are the node values, but we will be assigning values starting from 1 and going till the n. One is counting so loudly. Yeah. So after that, what we can do is basically be a lazy guy and copy upper code and write it here and create long answer equal to 0. And I can uh, add the integrity of that position to the answer. Yes. And return answer. So yeah. So what basically I'm doing here is that I'm again looping over rows array and uh, adding its integrity value. I am adding its integrity value of both of the elements, right? So let's say like there is edge between 1 and 2. So I have assigned 2 as 5 and 1 as 4. So the total importance of that road will be what? 4 plus 5, right? So that's what I'm basically doing here. I can also write it as, like to make you understand, I guess, a little bit in better way, that I can also write it in this way. Yeah, so it's one on the same thing. I guess I have to write that side. Yeah. So basically, yeah. So, but our time is, oh yeah, in Java, this system.out.println is a little bit costly, and we are basically printing an entire list, so it takes time. So sometimes you might get TLE just because of this print statement. So make sure you remove it. Here you can see that from 8 millisecond it became only 1 millisecond. So let's submit it. Got accepted, and we are almost 50%. After those many efforts, we are still average, but that's all right. We will get through. Okay. Hare Krishna. All the best.